14 years ago, a spacecraft called New Horizons flew past Pluto at more than 30,000 miles an hour, capturing the first close-up photographs anyone had ever taken of that distant, icy world. And then it kept going, deeper into the outer solar system, never to return. And since that flyby, Pluto has essentially been off limits to close scientific study, too small, too cold, too impossibly faint for any telescope on or near Earth to examine in the kind of detail that actually reveals new chemistry, new atmospheric behavior, new secrets. That should still be true today. And yet, in the past few months, scientists using the James Webb Space Telescope have done something that should not have been technically achievable, isolating a signal from Pluto's surface that does not match a single known chemical compound anywhere in our solar system. An absorption of light that, according to the researchers' own published account, appears in none of their models, matches none of their reference spectra, and corresponds to no substance ever previously identified on any planet, moon, or icy body humanity has ever studied. This is not an exaggeration dressed up for a headline. This is a direct quote from an actual peer-reviewed paper. Something is on the surface of Pluto that chemistry, as we currently understand it, cannot yet name. Stay with me. Because this is one of those rare stories where the phrase "it shouldn't be possible" is not clickbait. It is the honest, documented reaction of the scientists who found it. Let's start with why this observation was so difficult to make in the first place. Because understanding the scale of the technical challenge is the only way to appreciate just how significant the result actually is. Pluto is small, roughly 2/3 the diameter of Earth's moon, sitting on average about 3.7 billion miles from the Sun, out at the edge of what astronomers still call the Kuiper Belt. At that distance, Pluto receives a tiny fraction of the sunlight Earth does, and whatever faint infrared glow its surface and atmosphere emit back out into space is correspondingly dim, spread across wavelengths that ground-based telescopes and even earlier space telescopes simply did not have the sensitivity to separate cleanly from the noise. For years, one specific obstacle stood in the way of studying Pluto's atmosphere from a distance in any meaningful chemical detail. Pluto and its largest moon, Charon, are close enough together and similar enough in apparent brightness from Earth's vantage point that older instruments could not reliably tell the two objects. Infrared signals apart, whatever thermal glow scientists picked up was a blurred mixture of both bodies at once, making it essentially impossible to isolate what was actually happening in Pluto's atmosphere specifically, as opposed to its moon's surface. The James Webb Space Telescope changed that, and it changed it almost by accident in the sense that Pluto was never the mission's primary design target. Webb was built to look back toward the very edge of cosmic time, at galaxies formed within the first few hundred million years after the Big Bang, over 13 billion light years away. Turning that same extraordinary sensitivity toward a small, cold, comparatively nearby world like Pluto, just a few billion miles from home, is in some ways using a telescope built for the deepest possible view of the universe to instead take an extremely close, extremely detailed look at something practically in our own backyard. And it worked. Using an instrument called MIRI, the mid-infrared instrument, Webb was able to do something no observatory before it ever managed: separate the thermal signals of Pluto and Charon cleanly from one another. And in May of 2023, it captured a high-resolution mid-infrared spectrum of Pluto's atmosphere, spanning wavelengths that had simply never been explored before, because no earlier instrument had the sensitivity required to explore them. The first major result to come out of that data answered a question scientists had been debating since long before Webb ever launched. Back in 2017, a planetary scientist named Xi Zhang at the University of California, Santa Cruz, published a theoretical prediction that sounded, in his own words, like a crazy idea to many of his colleagues at the time. Zhang proposed that the high-altitude haze layers photographed by New Horizons during its 2015 flyby were not just a passive atmospheric feature, but were actively cooling Pluto's entire atmosphere, absorbing sunlight and re-emitting the energy as mid-infrared radiation, a mechanism nobody had confidently identified operating this way on any other world in the solar system. Zhang made a specific, falsifiable prediction alongside that theory. If the haze really was cooling the atmosphere this way, it should be detectable as a specific pattern of infrared emission, observable once a sufficiently powerful telescope came along to look for it. In 2022, once Webb's instruments were finally able to separate Pluto's faint signal from Charon's, that exact pattern appeared in the data, matching Zhang's 8-year-old prediction almost precisely. Zhang himself described the moment plainly, saying it is not common in planetary science to have a hypothesis confirmed so quickly, and that his team felt lucky and genuinely excited to see it happen. Pluto's atmosphere, the confirmed data now shows, runs on a haze-driven climate system that behaves like nothing else currently known anywhere else in the solar system, a mechanism scientists have compared to certain processes seen in the thick atmosphere of Saturn's moon Titan. but expressed on Pluto in a form unique enough that researchers are now calling it, in published statements, a genuinely new kind of climate. That alone would already be a significant discovery. But it turned out to be only the opening chapter of what this new data actually contained, because in a series of papers published across 2025 and into this year, the same observations revealed something considerably stranger. Buried in the spectrum Webb captured, researchers identified a specific, sharply defined absorption of light centered at a wavelength of 5.113 micrometers, a signal indicating that something on Pluto's surface is absorbing infrared light at that exact frequency. Under ordinary circumstances, identifying a signal like this is straightforward. Every known chemical compound absorbs light at its own unique, well-documented set of wavelengths, and scientists simply compare an unknown signal against a library of known reference spectra until they find a match. The research team, led by the planetary scientist B. Bezard and collaborators, did exactly that, running the observed signal against radiative transfer models incorporating every known gas and haze particle believed to exist in this environment. The absorption did not appear in any of those simulations. They then compared it directly against laboratory reference spectra for ethane, ethylene, acetylene, propane, benzene, hydrogen cyanide, and a range of other compounds already known to exist in the atmospheres and surface ices of icy outer solar system bodies. None of them matched. In their own words, the researchers stated plainly that they did not find any previously published band that corresponds to the location of the absorption they were observing. Here's where the story becomes genuinely strange, in a way that goes beyond a single unexplained signal on a single distant world. The researchers checked whether this same signature appeared anywhere else, and it did, on Saturn's giant moon Titan, a place so different from Pluto in almost every measurable way that finding the same unexplained absorption on both worlds is, by the researchers' own account, one of the most puzzling parts of the entire discovery. Titan is roughly twice the size of Pluto, sits far closer to the Sun, and is famous for having actual liquid rivers, lakes, and seas of methane and ethane on its surface. The only place in the solar system besides Earth known to have stable liquid on its surface at all. Pluto, by contrast, is a frozen, airless, seeming world locked in permanent, deep cold, with an atmosphere so thin it would register as close to a vacuum by Earth standards. There are very few obvious physical or chemical similarities between these two bodies that would explain why they would share a mystery compound that has never been detected on any other world anywhere at any time. The researchers took an additional careful step to make sure the signal was real and not some artifact of atmospheric interference, checking whether the strength of the absorption changed depending on where across each body's visible disk they measured it. If the signal came from something in the atmosphere itself, it should have appeared stronger near the edge of the disk, where light passing through to reach Webb's instruments would travel through a longer path of atmospheric gas before escaping into space. Instead, the researchers found the opposite. On Titan, the absorption was actually weaker near the edge of the disk and stronger toward the center, a pattern that strongly indicates the signal is coming directly from the solid surface itself, not from any gas floating above it. On Pluto, the same mystery absorption showed up as well, but with its own distinct signature, roughly 3 times wider than the version detected on Titan, though of a broadly similar depth and strength. That difference in width, according to the research team, could turn out to be one of the most important clues toward eventually identifying what this substance actually is, potentially reflecting differences in temperature, surface composition, or the physical structure of the ice grains involved in each location. So what is it? Right now, honestly, nobody knows for certain. And the scientists studying this signal are saying so directly rather than rushing to a premature answer. The paper proposes several plausible candidates, worth further investigation, rather than a confirmed identification. One possibility involves a class of organic compounds called allenes, unusual hydrocarbon structures that do produce absorption features in roughly the right part of the infrared spectrum. Another possibility involves benzene mixed with some other, currently unidentified molecular species, a combination that could shift benzene's normally well-documented absorption signature into a new, unfamiliar pattern. A third possibility involves some form of acetylene or ketene ice, existing in a physical state or mixture that has simply never been measured in a laboratory in exactly the configuration these two distant worlds happen to present. Every one of these explanations remains genuinely unconfirmed, and the researchers themselves state clearly that considerably more work, likely involving new laboratory experiments, recreating the extreme cold and vacuum conditions found on both Pluto and Titan, will be required before anyone can say with confidence exactly what this substance is. This finding does not exist in isolation. It arrived alongside a wave of other genuinely new discoveries about the Pluto system, all made possible by this same unprecedented ability to finally study Pluto and its largest moon separately and in fine chemical detail. Earlier observations from the same Webb dataset had already confirmed something New Horizons first hinted at back in 2015, an interaction between Pluto and Charon that occurs nowhere else in the solar system. Material actually escapes from Pluto's thin atmosphere and drifts across the roughly 12,000-mile gap separating the two worlds, eventually settling onto Charon's north and south poles, where researchers believe it undergoes chemical transformation into the dark, reddish material that gives those polar regions their distinctive coloring. It is, in the most literal sense, one world's atmosphere slowly raining down onto its own moon, a genuinely unique planetary relationship that Webb's new data has now let scientists study with far greater precision than ever before. In a separate study published in October of 2024, a research team led by Silvia Protopapa at the Southwest Research Institute used Webb's near-infrared spectrograph to identify carbon dioxide and hydrogen peroxide on Charon's surface for the first time, two compounds that had eluded every previous instrument capable of studying this small, distant moon. Protopapa described these findings as expanding Charon's known chemical inventory in ways that could reveal important clues about its ancient formation and its long history of exposure to radiation drifting through the outer solar system, evidence embedded directly in the moon's icy surface of processes that occurred billions of years ago. Put all of this together, and you get a genuinely remarkable picture of what has actually happened here. A telescope engineered primarily to observe galaxies at the very edge of the observable universe, more than 13 billion light-years away, has also managed to do something that should, by every reasonable measure of Pluto's faintness and distance, have remained just barely out of reach. It separated the infrared signatures of two small, cold, closely spaced worlds that no previous instrument could distinguish from one another. It confirmed an 8-year-old theoretical prediction about an atmospheric cooling mechanism that exists nowhere else known in the solar system. And in the process of doing all of that, it stumbled onto a chemical signature that does not match any known substance ever cataloged by planetary science, appearing mysteriously on two worlds separated by hundreds of millions of miles and almost nothing in common physically, except, apparently, this one unexplained molecule. It is worth being precise about what is and is not actually being claimed here, because that precision is exactly what separates a genuine scientific mystery from manufactured hype. Nobody studying this data is suggesting anything exotic in the sense of alien technology or impossible physics. What is genuinely, verifiably true, stated plainly in the researchers' own published words, is that a specific, carefully verified absorption signal, confirmed to originate from solid surface material rather than atmospheric gases, appears on two distant icy worlds and corresponds to no chemical compound currently documented in any laboratory reference library available to planetary science. That is an authentic, unresolved puzzle, not an exaggeration. It may eventually turn out to be one of the candidate molecules the research team has already proposed, once laboratory experiments manage to recreate the exact cold, low-pressure conditions found on Pluto and tighten closely enough to produce a matching signature. Or it may turn out to be something nobody has proposed yet at all, a genuinely new addition to the catalog of chemistry known to exist naturally in our own solar system. Either way, this discovery says something remarkable about where planetary science currently stands. More than 5 decades after Pluto was first discovered, and nearly a decade after New Horizons gave humanity its first ever close-up photographs of the place, we are still finding entirely new categories of unanswered questions about a small, cold world sitting right at the edge of our own solar system. Not because Pluto itself has changed, but because our tools for actually looking at it keep improving in ways that reveal details no previous generation of instruments could ever have detected. Webb was never designed with Pluto as a primary target. It found this anyway, almost as a byproduct of being sensitive enough to separate two faint, closely spaced infrared signals that had been blurred together in every previous observation ever made. That is, in its own way, exactly what real scientific discovery looks like. Not a dramatic, singular reveal, but an instrument built for one extraordinary purpose, quietly uncovering something nobody was specifically looking for, sitting in data that had simply never been possible to collect before. The mystery molecule on Pluto and Titan remains unidentified as of right now, in the middle of 2026, and researchers are continuing to study both worlds, hoping additional Webb observations, combined with new laboratory work here on Earth, will eventually let them put an actual name to whatever this substance turns out to be. Until then, the honest answer is the most interesting one available. Something is sitting on the frozen surface of a dwarf planet 3.7 billion miles away, and on the icy, hydrocarbon-streaked surface of a moon orbiting Saturn, nearly 1 billion miles closer to home, and nobody currently knows what it is. If you want to know the moment scientists finally identify what this mystery substance actually is, subscribe and turn on notifications. Because this is a real ongoing chemical mystery playing out in the outer solar system right now, and the answer, when it finally comes, is going to be worth hearing explained properly.